All right, good. Yeah, so yesterday we discussed about or we did the practicals on descriptive statistics. Yeah, that's true. And we did that is measures of central tendency and also measures of variability. But for measures of symmetry, I said that we'll discuss that topic on a later date. So we are yet to that is to cover. We are yet to cover. We are yet to cover covariance and what and correlation. Okay, we are yet to cover covariance and correlation. So now I want us to use our yesterday data set to compute for covariance. But before then, I want us to remind ourselves the formula for covariance. Okay, so remember, that is on our discussion covariance. We said that covariance, let's say of two variables, x and y, okay, it's calculated by summation of xi's minus x bar, okay, multiply by yi's minus y bar. Okay, then divide all of this divide by n. This is the covariance. And remember we said that covariance shows us the joint variability of two variables. Okay, and our variables here, they are x and what and y. These are the two variables. So basically what we are trying to check, it's the product, that is some product, or let's say product of what of their difference. Okay, of their, that is of the data point difference from the what from the mean. That's why you can see we have variables for x, that is the xi's minus the sample mean for what for x, and you multiply by, that is the second variable, that is the yi's, and these are the observations for y, and then you minus by what you minus, that is the sample mean of what the sample mean of their, that is of the data or of the second variable. Then of this you divide by n. In this case, n is equal, that is for xi's and yi, n is what n is equal. All right, n is equal. Like for example, if we have 24 observations of xi's, okay, we should also have 24 observations of what of yi's. Okay, and this will get this, that is from what from the two or from the data set we have. Let's take the example of our data set. We have the amount of rainfall, okay, and also we have what the umbrella cells. Okay, so you can see we have two variables here, that is the rainfall and umbrella cells. So we'll take the rainfall as x, and then the umbrella cells as what as y. Why not rainfall y and that is umbrella cells x? This is because remember from yesterday, that is I said that we are using the amount of rainfall to do what to predict the umbrella cells. Okay, so basically why, that is umbrella cells will be what our y. Why? Because this is our output. What we need, it's what it is the umbrella cells. Okay, so meaning it is our what it's our output. All right, then It is also known as the dependent variable. We shall check that when we'll be dealing with linear regression. Okay, and that's why now, because we need our output to be like we are predicting the umbrella cells depending with the variation in terms of what rainfall. Okay, so and then by default rainfall will now become what, our x value or our independent variable. Why? Because we are using x to predict what, to predict y. All right, so that's how now we've defined our what, our variables. Okay, yes, now that's how we will manually calculate what, calculate the covariance of the rainfall amount and what, and the umbrella cells, and see, okay, what can we conclude from the value which we get from what, which we get from our value. And remember, I also say that covariance ranges between negative infinity to what, to infinity, meaning you can get you can get a covariance of negative 690. Okay, you can also get a covariance of 90,000. Okay, yes, so the covariance values run between what, or range between negative infinity and infinity. Now let's go to the correlation. Okay, correlation. Now, correlation, to calculate correlation, we need we need we need that is covariance. We'll now take covariance. We'll now take covariance of x and y. Okay, divide by what? Divide by now, okay? Divide now by standard deviation of x, multiply by standard deviation of what? Of y. So this is the mathematical formula for what? This is the mathematical formula for that is covariance, or correlation, sorry, of correlation. So correlation is given by covariance divided by standard deviation for the both what, for the two value or product of that is of the standard deviation for the two what, for the two variables. Good. Now I think we can now go to the practical part of it. Okay. We need now the practical part of it. So let's now dig in now to the practical. Let me just that is enlarge this. So what we need now, okay, remember from our formula, we need now this. Okay, and also we need what, we also need this, because we know this is 24, n is what, is equals to 24. So now we need to compute this and then compute this. Okay, and we'll get what, and we will get that is our covariance. Good. Now let's start. We are going to start. This is our x, remember that, and this is our what, our y. This is our x, this is our y. So I want us to start with that is the x. So let's compute the mean here. Let's just recompute the mean. Of course, here we will need mean, and also I will that is compute STDEV, that is standard deviation, okay, for the two. So I will say that is equal to mean. We said what is mean? Mean is the simple average. So we are going to use the average function. Okay, so I'll just highlight the whole data. Okay, and here I need what, now the standard deviation. Since this is a what, this is sample data, so I will say equal to standard dev of what, of a sample data. and then I will highlight my what? My range up to what? Up to December of 2017. Okay, and close that. So we have what? We have our mean and standard deviation for rainfall and umbrella cells. You can still do the same if maybe, and if you are lazy like me, you can just drag it and it will auto, that is calculate. Okay, for what? For y. And here are the values for y. And then you can always, that is the reduce, that is the number of decimals if you like to. All right, now let's go to the first part of the, that is of the formula, which is xi minus x bar. And I hope we are all together. We already have, that is the value of x bar. Why? Because we've calculated x bar here. You can see this is the mean, the sample mean. Before I can continue, are we together up to that point? So that we may, that is, move forward together. Are we together up to that point?
Yes, mwalimu.
Ye-
I-
Yes,
For
that.
me, we are together.
Okay, nice. Thank you, Nancy. Who else?
We were together.
Okay, yes, Kwamboka, I can see your hand is up.
No, I've raised my hand to show that we are together.
Oh, nice. Thank you, thank you. At least we have now a third person, third active person. No, let's say fourth because of Ephraim, that is Ephraim. Others, like I've never had, that is the voices from, okay, let me check that. We've never had voices from, okay, from Fiona. Fiona Dhumbi, I've never had you. Philip Walpole, I've never heard from you. Um, for Venetia, I think I heard your voice during the first class. Yeah. So please, and also Gonka Shanice. Okay. Yeah. So please make an attempt so that we may also hear, that is, your voice. Okay. Thank you. Otherwise, let's continue. So now here we need to calculate what? That is the value of xi minus what? X bar. And you can see it is not squared here. Okay. So for covariance, we don't square, unlike in when we are computing variance. Okay. Yes. So with that, we are going now to compute for the value for xi minus, let's say, x bar. Let's say it is x bar. Okay. So it will be equal to xi's. These are our xi's. You can see these are our xi's. So I'll just take xi minus our x bar. And since we have, that is, we've already calculated the value of x bar, okay, we will now have to lock these cells. Okay, we'll have to lock these cells. And to lock these cells, I said you put a dollar sign at the beginning of that is cell, and also between what? Between the alphabet and what? And the numbers. Okay. Then you run. Once you run, you can what? You can drag down. Okay. Up to where, that is the data, at the end of the data. Okay. All right. Then you can still do the same. Now we need, that is x what? Sorry, yi minus y bar. Okay. We need yi minus y bar. Okay, so with that we'll say equal to now this value, okay, minus our mean. Then remember to log what? Remember to log also the mean for what? For the umbrella cells. Okay, once you log, you can drag it down. Okay, just drag it down, and then we are okay. We are good to go. And as you can see, it's like we are almost done with what? With the numerical part of the formula. We are done with what? With this part. In short, we are done with that is let me show you. We are done with xi minus x bar multiplied by that is multiplied by yi minus y bar. We have, and then we also have summation here, then n. We've calculated this, we've calculated this. Okay, now we need what? We need the xi minus x bar, okay, now multiplied by x, that is yi minus y bar. This is what we need, meaning we are going to uh, multiply this value, the value of this, multiply by the value of this. And then after doing that, we'll find a summation, okay? Meaning we are going to add all those values under this column, okay, to complete summation. And then after that, the value we get, we can now divide by what? We can now divide by n, okay? We can now divide with the, that is the observation. So the combined, let me just take the formula here. Okay, sorry. Okay, okay, let me complete this. So in summary, this is what we need. Okay, so with that, you'll just say equal to this multiply by this. Okay, and then you will get a positive value where we have two negatives. Why? Because a negative multiplied by a negative, it's what? It's a positive. And then we are going to drag it down. Okay, yes. So now after that, what we need now, it is the summation. Okay, so we are going to compute the summation here. What we need is summation of that. We need summation of that here, okay, of this. So to do that, we are just going to say equal to sum, okay, of all these values. What we need is just the summation. So we are done with the upper side or the numerator. Okay, so we are done with all of this. What is now remaining? It is what? Dividing by n. So here we are going now to compute now the covariance. The covariance now, the covariance will be now given by equal to this, okay, divide by what? Divide by our n. So that is divide by 24. Okay, so this is what? This is the value of covariance. And I just a minute, I want to confirm if under covariance, sometimes it might confuse. If under covariance we have what? We have maybe divide by n minus 1. Let me just confirm so that I may not have that is doubt. Uh, Covariance. Okay, yes. It seems we have Yes, it seems we have it is n minus 1. Can see for sample it is n minus 1, so we will have to that is minus 1. Okay, so it will be n minus 1. So here, instead of dividing by 24, we'll divide by 23. And then this is what? This is our manually computed what? This is our manually computed covariance. I hope we are together up to that point. Are we all together up to this value? How we've calculated this value?
Yes, Mwalimu, we are together.
All right, nice. Okay, good. Now let's do confirm if our computation are what? Are correct. And how are we going to do so? We are going now to use the Excel inbuilt function. In fact, we have two methods. We can see if we use the inbuilt Excel function, or if we can also use the data analysis tool pack, which we added yesterday. So let's do that is the both. So we are going now to compute covariance using that is the Excel inbuilt function. And for that, the function is called covariance. Okay, and you can see we need covariance for what? We need covariance for us, that is for a sample data. Okay, you can see return sample covariance. That is the average of products of deviations of each data point pair in the what? In the two data set, or into within the what? The two variables. Okay. Yeah, so we are going to take covariance of sample data, and then after that you can say it is required, or it is we are required to that is to highlight the first array, and then we go to the what? To the second array. Okay, so array basically it is the range of our data. Okay, so we are going to highlight all the cells containing that is the rainfall amount. Okay, then after that we'll do a comma and also highlight the that is the range for the umbrella what? For the umbrella cells data. And then after that you can just run. Okay, if you run, you can see we are getting what? We are getting the same value. Okay, you can see we are getting the same value. All right. Okay, so let's try the data analysis tool pack and see if we get that is if we get a value like this. Okay, and maybe there is a possibility that we won't get a value like this. Reason being, for the data analysis tool pack mostly uses that is population, or assumes population. Okay, it assumes population data. In most cases it assumes population data. All right, so we are going to do what? We are going to check if that's the case. Okay, so with that, now we will go to the data analysis. Then you will see covariance. Yes, there is someone has lifted and yes, kwa boka.
Yes. How did you get that data analysis
Oh,
tool?
so yesterday you were not in the class.
Yes, I was not there.
Okay, but did you manage to follow the video? Because I also gave illustration with that, but I can still repeat for your case. Okay?
Okay.
Yeah. So go to file, Okay, once there, you can let me know. Go to file,
Yes.
then go to options.
Mm-hmm.
Then under options, we have add-ins.
Okay.
Then after add-ins, click go. You will see go somewhere.
Okay.
Then click check the that is the checkbox with analysis tool pack,
Yes.
and then click OK here. Then after clicking OK, go to data tab here and see if you can see the data analysis
Yes, I'm
icon.
able to. Thanks.
Okay. All right. So we are going to just you can now use the data analysis tool pack. So just click it and then go to covariance. Okay. Once you go to covariance, click OK. All right. After that, it will tell you to input the data range. Okay. So to input the data range, you only need what? You only need that is you can select from even the titles, but make sure you check this and say the label that is labels in what? Labels in the first roles. Okay, but for this case we can just highlight where we have the data. So okay, up to that point, then we need the output just here in this worksheet, and I need the output here. Okay, so once you click where you need the output, then click OK, and it will give you that is the covariance. So it is, though it is giving us covariance in terms of what? In terms of matrix. Okay, in terms of matrix form. So I would advise if we can use for the that is for the covariance, we can use that is the inbuilt function in what? In Excel, if we can use the inbuilt function in Excel. Okay. Yes, let me try and check what. Otherwise, you can see when we do the population, that is the statement which I made. You can see if you use now the population covariance, you are getting what? You are getting this value. Can see it, you are getting this value. That's why I said in most cases that is the analysis tool pack assumes the data in is what? It's population data. Okay. Yes. Otherwise, you can always use that is the inbuilt function just to be specific. Okay, so that you may be specific with your computations. Any question about covariance before I can go to that is I can proceed to covariance to correlation. For my case, I have a question. I don't know from your side, but let me ask before you can ask. So basically, we've gotten 300.5358 a value. So what does this number mean? What does this number mean? Because this seems to be just a number to me. What does this number mean? And I think we discussed that is in length about covariance. What does it mean? Someone?
Pardon the question kindly.
So what does this number mean? Okay, we've received or we've gotten that is an output of 300 as our covariance. So
Mm-hmm.
what does it mean in terms of covariance? What does the value
Uh,
mean in terms of covariance?
I think just a trial.
Okay.
Uh, increase in rainfall leads to an increase in the number of umbrellas being sold
Yes,
because
yes, that,
it's a positive relationship.
yes. Okay. Yeah. So remember we discussed about covariance, and we said that covariance gives us the directional what? The directional relationship between two variables. Okay. So we can conclude and say it is evident from from our data that any increase in rainfall also triggers what? Also triggers an increase in what? In the umbrella cells. We can say that. Increase in the amount of rainfall triggers an increase in what? In the number of umbrellas sold. Okay? Yes, that's what we can. This will mean. Why have we said increase instead of decrease? This is because the value which we've gotten here, it is a positive what? It is a positive that is value. Okay, so we can say increase in that value has led to increase on the other variable. Okay, good. Now I think we are now set to go to correlation topic, unless someone has a question.
I have one question in regard to the number,
Mm-hmm.
the 300. So it doesn't matter the value, whether it's 1,000, 20,000, as long as it's positive. The only purpose of this is to show whether it's the direct transition. I mean, sorry, direct relationship
Proportional,
or
yeah.
negative, positive and negative. That's it.
Yes, that's it. Correct.
Uh, okay, thank you. The other one which I wanted just to clarify so that you can clarify when we did this covariance using the data pack,
Uh-huh.
uh, three digits or rather three results came out,
Mm-hmm.
including the 288.
Mm-hmm.
I didn't understand where the other two values, column one had two and column two had one, which is 140,
Yeah,
and the
so
column.
so basically that's why I disregarded that formula or that way of computing covariance, because with that it is giving us a matrix, okay? Matrix of the values, okay? And sometimes you might find it is hard even to get which is the correct value to use. Okay, so for covariance, that's why that is I've advised if we can use the Excel function. Okay, otherwise maybe for the other three values I won't lie, but you can go and research and check why is it giving us three values? Why is it giving us the results in matrix form and not just one value? Okay, so that's something subjective to research. You can go and check that, and then uh, we can maybe brainstorm on the same from that is the next class. Okay, that's okay, Samuel.
Yeah, that's fine. Thank you.
Okay, okay. And also, remember, I think yesterday, yes, I gave you that is a question. Okay? Yes, I gave you a question like, why in sample data, why are we minusing one, okay, when it comes to sample size, but in population we are just using what? The n. But for the sample size, we are taking n minus what? Minus 1. Still, I still remember that. I gave you that as an assignment. Then also keep it in mind. All right, good. Now let's go to covariance. Here it's the formula for covariance. That is for correlation. We already have what? We already have the covariance, and also we have what? The standard deviation for the what? For the two, that is for the two variables. Okay. Something to remember about correlation. Remember we said that is correlation ranges from -1 to 1. Okay. And then we did a number line last time, and we said we have a 0 here. Okay. Here we have 0.5. Okay, and here we have what? 1, positive 1. Here we have negative 0.5, and here we have negative 1. Okay, remember we said this, if we get a value of 1, okay, we will say that that is the relationship between the two variables, let's say x and y. It is perfectly that is positive relationship, perfect positive relationship. Okay, we also said that is any value may be greater than 8, that is 0.8, that is 80%. Okay, we said it is said to be a strong positive relationship. Anything less than that, it becomes what? A weak positive relationship. Up to what? Up to 0. Then we said 0 means that we don't have any what? We don't have any correlation, or there exists no relationship between what? Between the two variables. Okay. Yes. All right. And then the same here. We said here it's what? It is perfect negative. That is correlation, relationship. Let's say relationship, and anything which is that is above this, it will now be strong. That is negative. This is n. Sorry, don't confuse. This is n. A strong negative relationship. Anything will become now weak negative relationship. Take note of that. That's what we will use to do what? That is to compute for the correlation. So now let's go to manually compute correlation. That is, yes, correlation. So here we'll say correlation, correlation. So we will say that correlation, we've said it is covariance, okay, which is this, divide by, that is product of this and this. Okay, so it will be into brackets this, which is the standard deviation of the first variable, multiplied by the standard deviation of the second variable, and then we'll get a value. So you can see our value here. Our value, we are getting 0.95. What does this value mean? What does 0.95 mean?
They have a strong positive relationship.
Yes, here we have a very strong positive relationship between what? Between the two variables. Okay, meaning that is one variable explains 95% of the other variable. Okay, so the two variables can explain each other 95%. Okay, like for example, if that is logically we know, if the amount of rainfall increases, okay, most of the people will buy what? Will buy umbrellas during that season. Okay? Like for example, even before we can go to that point, let me try and show you that is the pattern, okay? The rainfall pattern for these two variables. Okay? Let me check the rainfall pattern. Okay, so check out this. You can see this is the rainfall pattern and also the umbrella cells. Okay, let me change this to cells. Okay, you can see this is the umbrellas, that is a rainfall pattern and the umbrella cells pattern. Like for example, let's check the months which we have what the highest amount of rainfall. It is what? It is July. If let me just invert that so you can see it is July. You can see where we have a series here. Okay, I don't know how I can present that. You can see we have a series here. Okay, and you can see that is the month is July, and the amount of rainfall at that month it is 165.4. Okay, so we can say this month we expect to have the also to have the highest umbrella cells. Is that the case? Let's now come to the umbrella cells distribution. Yes, and you can see the maximum amount of rainfall, that is the maximum amount of umbrella cells, it's 50. Okay, and you can see this 50, it is all these cells were done when we had the what? The highest amount of rainfall. Okay, and you can see it happens almost throughout every what? Every month, every July. Okay, you can see this is the first July of 2016, and also we have the July of 2017. Okay, so you can see we are having the what? The highest amount of umbrella cells during the period where we are having what? We are having a high amount of rainfall. Okay, so with that it explains that that is the amount of rainfall. Okay, or the variable rainfall. Okay, explains more about the that is the umbrella cells pattern, or the rainfall amount pattern also explains 95%. Okay, it explains 95% of the umbrella cells. Okay, and you can see it is a positive relationship, meaning increase in rainfall will also trigger an increase in what? Will also trigger an increase in the amount of that is the rainfall. Okay, sorry, in the amount of umbrella cells. Any question under correlation?
Sorry, Malima, just one question.
Mhm.
Okay. I'm getting the gist of this whole correlation and covariance thing. I'm trying to figure out if you have like huge data, huge different data, not necessarily two variables, and you want to to get to single out the events that are maybe either have a positive relationship or a strong correlation. Is there a formula like can you can do it? Not necessarily two, but you want to single out the two. I mean, two. I don't know whether you understand the two from these huge. I mean, events of transaction or whichever case may be, and you want to see the relationship of each other to single out the two that have such, I mean, covariance is positive or negative and correlation is strong.
Yes, I get your question. Like your question is, assume we are having more than two variables, right? Like we are having, let me just take an example. Okay, let's assume we are having salary. Okay, we have education level. These are the factors which affect what? Salary. We also have skills, and also we have experience. So you can see we have what? Different, we have more than two variables here, okay? And these three variables affect what? Salary. So we want to see out of these three variables, which variable majorly affects what? Majorly affects as the great, that is the largest impact on the what? On the salary. Okay, let's assume now we have the data here. Okay, so with that, it is very possible you can do what? You can do that is a that is correlation. For covariance, I can't promise. I'm not sure if you can do for multiple variables, but for correlation, I know you can do for multiple. Okay, why? Because it will give us that is all, it will return what we call that is correlation matrix. Like for example, if I go with these maybe these two variables, okay, and then go to let me go now to the that is the data analysis. Okay, then I'll go to correlation, and under correlation I will select my that is my variables. You can even that is highlight to more than what? Two variables. Okay, and I want my output to be just here. Okay, and then run. So with that, you can see we have what? We have that is a correlation matrix. Okay, so let's go with column 1 and column 1. Okay, so it's like we are trying to check the correlation between the amount of rainfall and also amount of rainfall. Definitely it will be a perfect positive correlation. Why? Because it's the same data. Okay, no difference. It 100% explains itself. Okay, but you can see now the correlation between that is column 2 and column 1, which is that is column 2 and column 1. So it is, you can see it is checking the relationship between what? Between the umbrella cells and the rainfall amount. Definitely that in that case we will have a value, and our value, you can see it is the same as the value we got when we used what? We used the manual computation. Okay, so with that, you can see we have a correlation between column that is column 1 and what? And column 2. Okay, though in Excel it might be tedious, but when you will be learning that is introduction to Python programming, you will there is a that is a topic where you will do correlation of of what? Of more than two what? More than two variables. Okay, and it will return what we call that is a correlation matrix to give you what? To give you that is correlation between what? Between different variables. So in case you have another variable, it will bring that is column. It will give us it will include another column 3 here and also column 3 here, where you will have maybe to check. Okay, you will have to check like that is the relationship, or in terms of correlation, how is that is variable 3 correlated with variable A, how variable 3 is correlated by variable 2, how variable 3 is correlated to variable 1. Definitely that is the variable 3. Definitely that here you'll get what? A 1. Okay, but here you'll get a different value. I think I was clear on that.
Yeah, thank you. Very well explained, well noted. Thank you.
Okay, another question? Yes, clear.
Mm, from what I've understood,
Mm-hmm.
when you have covariance and correlation, when one is positive, the other one must be positive. Is there a scenario where one is positive and the other one is negative?
I've never came across that case.
Okay.
Yeah, I've never come across that case. If it is a positive here, in most cases, you'll find that the correlation is still positive. Okay, because you can see they are moving on the same direction. Okay, and here
Yeah.
they are increasing. Okay,
Okay. Okay.
yeah, so you don't expect here to decrease. But
Okay.
if
Thank you.
maybe this was decreasing, here we could have gotten what? A negative.
A negative. Okay.
Yes. Yes.
Thank you.
Okay. Good. I think we are done with those practicals. Now I just want, because I can see the time has really moved, I want us now to introduce that is to introduce linear regression, okay, or regression analysis. Let's talk about regression analysis. Here we'll talk about predictive predictive models. Predictive model, because under regression analysis, more so the linear regression analysis, okay, we talk about a predictive model, like how can we create a model, okay, that will predict maybe the future sales. Like for example, we are predicting next month the amount of rainfall will go down, okay, or the amount of rainfall will be high. Okay, so depending with the value maybe which we are trying to assume, okay, we can now compute the amount of that is all the number of umbrellas we can sell. So in that case, it will help us get the idea of that is how we will restock how we will restock our that is our shop, okay, or our umbrella outlet. Okay, good. Now, I want us to start with a model. Give me a model. Can someone know of a model? But let me just give you a model. What is this? If you can recall this back in high school, what was this? What was this? Who can remember? Oh, it is with okay. Linear equation. Yes, it is. Yeah, it's a linear equation. But majorly we were calling this equation of a straight line. Of course, now the straight line it's the thing which is now it is giving us now the linear equation. Remember, this was what? The equation of a straight line, okay? Which it's a linear, okay? Yes. Then, what was our y? What was m? What was x? And what was c?
I think y was the dependent variable,
Yes, this is the dependent variable.
then x is the independent variable.
Yes, x is the independent variable. What about m
Then
and c?
c was a constant.
Which constant?
I don't remember
It is
that.
the y-intercept.
Yeah, and m is it was the slope of the
Yes, the
line.
slope. Yeah, very correct. So maybe graphically we were presenting it this way. So let's assume, just assume this is a straight line. Okay, just assume this is a straight line. So here we have some data points which are not along the straight line. Then if we extrapolate this that is this line, okay, where the line was cutting the the y-axis. Remember, this was the y-axis, this was the x-axis. So the point where this line was cutting the that is the y-axis, okay, then that became that became our y-intercept, which was the c, the constant c, okay. Then we had the x. The x was the independent variable or predictor variable. We usually call them predictor variables. Why? Because they predict what? They predict that is the output of what? Of y. Okay? They predict this. This is called a dependent variable or explanatory variable. Okay? And then we have the slope. Okay, the slope meaning it shows us the change. Okay, yes, someone has raised hand. Yes, Kwamboka.
Yes, yes, I just missed on that part for the predictive variables.
This that is it is the another that is predictor. It's not predictive, it is the
Mm-hmm.
predictor variable. The independent variable, it's also known as predictor variable because it is used to predict what? Our dependent variable. Okay.
That's okay, thanks.
Yes. So, and then we have the slope. Let's take maybe the example of slope. We could remember we could draw a straight line that is, or a triangle, which that is a right angle triangle. Okay. So let's assume this value is at 10. Okay. Let's assume this value is at 5. Okay, also let's assume this it is at maybe 6, and this is at what? Is at 10. Okay, remember the slope was given by what was the formula for the slope? Is it change in y divided by change in x, right? I guess so. So that will be change in y, which is the vertical change. It is 10 divided by what? 10 minus 6, sorry. This would be 10 minus 6, which divide by 10 minus 5. Okay, you can see. Now this is the what? Change in what? Change in x is 10 minus, it would be 10 minus what? Minus 5. And this would be what? This would be that is 4 divided by 5, which would be what is this? Is it 0.75?
0.8.
It is 0.8. Okay, 0.8. So this would be what? Would be our slope. Let's assume now here it cuts the y-axis. This line cuts the y-axis at what? At this point, that is 2. Okay, so our we know now our m is what? Our m is 0.8. Our c is what? It is 2. Okay, now we can now that is use the model now. So our model will be equal to y is equals to m, which is 0.8, x, we don't have the value of x, and depending with the value of this, so this is a positive, then plus what? Plus 2. And this would be our linear equation, okay, or our predictive model. Why? Let's assume maybe this is we are talking about maybe rainfall. Okay, now and umbrella cells. Okay, so let's assume we are expecting that is amount of rainfall here, okay, to be, let's say, 20 in a new, that is in the next month. We are expecting the amount of rainfall to be 20 millimeters. So our what will be our projected, or what will be our projected what umbrella cells? So it will be 0.8 multiplied by 20, right, plus 2. And this would be what? This would be, is this is 16? It would be
18.
18. It will be 18. So we will be expecting 18 umbrellas at this point. Okay? Yes, at this point. Yeah, so that's how we will build our model. So now in tomorrow's class, we'll just now go through that is the theory. We'll discuss also assumptions which we usually take when doing a linear regression. Like we have assumption of autocorrelation. We also have assumption of co- autocorrelation. Then we have correlianity, and also we have heteroskedasticity. Very big terms, but with that is with very well explained in what, in simple terms. So I think for today I'm going to stop there. Okay, for today.